Section 2.7, absolute value functions. So remember that an absolute value is a distance from 0, so it's always going to be a positive number. When we start graphing absolute value functions with an x and a y, the graphs are always going to be a v. So some basic information: the parent function of an absolute value function is f of x or y equals the absolute value of x. So if you think about this, this means that for every point x, y on the graph, if I plug in negative x, because the absolute value makes it positive, the point negative x, y is also going to be on the graph. The transformation of a graph changes its size, shape, position, or orientation. This means that it's going to let you know whether it is a skinny V or a wide V, or whether it opens up or whether it opens down. A translation is going to tell you whether the graph shifts horizontally or vertically, how it's translated. As we look at the equation of an absolute value, y equals a, absolute value of x minus h plus k. The idea of this a, h, and k is going to be a recurring theme with any kind of graph that we're going to be dealing with in this class. So the faster this makes sense with you, the easier subsequent graphs are going to be. So please make sure you're asking questions if you're not still fully understanding them. So the hk in an absolute value graph is going to be the vertex. So x minus h. The h, since it's grouped with the x, is going to tell you how much that graph is going to shift left or right, because the x-axis goes left or right. The k, on the other hand, because the y-axis goes up and down, is going to tell you how much that graph is shifted up or down. The a is the idea of a slope. It's going to tell us how steep or how skinny or how wide the absolute value graph is going to be. Okay, so let's jump in and graph one of these. The vertex of this first graph, y equals the absolute value of x minus 1 plus 3. Remember that whatever's grouped with the x, so my vertex in this graph, it's x minus 1. It was x minus h, so my x-coordinate is going to be 1. And it's plus 3, so my y-coordinate is going to be plus 3. So we're going to graph 1, 3. So that's where my vertex is. And then the number that's out in front of the absolute value, what's being multiplied by the front of the absolute value, is a 1. So it's going to have a slope of 1. So we're going to graph a slope of 1. And then we also have to graph the other side. So this is also going to have a slope of, it's going to actually be a negative 1. So that's why I said, kind of in air quotes, what the slope of the graph is. So that's the graph of the first absolute value function. So the second example, again, the first thing we need to do is determine where the vertex is. So we're looking at whatever is grouped with the x, and we see that there's nothing grouped with the x, so it's going to be 0. And then what's being added outside the absolute value is also a 0. So my vertex for this problem is going to be 0, 0. So we're going to plot that. And then you'll notice in this case, my a is 1/3, which means my slope going up to the right is going to be 1/3. So we're going to go up 1 over 3, up 1 over 3, up 1 over 3. So this is going to be the right side. And then again, we have to go up 1 and back 3. So we're still going to use the idea of slope. And this is how we're going to make our v. So it's going to be up 1, back 1. That's how we have our v for the second problem. Okay, this third and fourth example, I might actually challenge you to turn off the video or pause the video and try to do these two problems on their own. Otherwise, we will go through them. So again, for the first example, or for example C, my vertex, the value that's grouped with the x, so remember if I were to write this as x minus, it would be x minus a negative 3. So my vertex is going to be at negative 3, and then the value that's being added or subtracted outside is going to be negative 2. So again, I'm going to graph my vertex, back 3 and down 2. And then again, my a value, I need to determine what my a value is. And my a is the number that's being multiplied by the front of the absolute value. So in this case, it's 1/4. So again, my slope is going to be 1/4. So I'm going to go up 1 and over 4. And I'm going to do this a couple times so I get a true value of look of what my absolute value looks like. 1, 2, 3, 4. And then I need to do the same thing in the other direction. So up 1 and back 4. And up 1 and back 4 again. And when I draw in my v, this is going to be a really, really wide v. And there we have the graph of example C. Example D. Once again, we determine what the vertex is. In this case, my vertex is going to be -1, -2. So I'm going to graph, oops, I forgot to write my negative. -1, -2. And in this case, my a value is a -3. So again, if we think about this as a slope, it's -3 over 1. So we're going to go back, rise over run, down 3, back 1, down 3, back 1, down 3, back 1 in this direction, and down 3, back 1. So again, you'll notice this is a negative a value, so my absolute value is going to open down. And now we have two examples where we need to write the equation of the absolute value. So again, let's just write down what that general form is. Absolute value a times the absolute value of x minus h plus k. So we need to determine our vertex is our hk. So if we look at this, 1, 2, 3, 1, 2, 3, 4, my vertex is at 3, 4. So I really can just plug those in for h, x minus h plus my k. And now I just need to determine what my a value is. So it's opening down, so my a value is going to be negative. And then I just need to find 2 points where it goes through. So it seems to go through the origin and that point. So if I look at my slope is going to be a rise, 1, 2, 3, 4, and a run of 3. So it's going to be a -4/3. It's kind of hard to see that negative out in front because of the equal sign. But it is a -4/3 absolute value x minus 3 plus 4. And again, we're going to write an equation of this absolute value. So again, let's just write down that generic formula. Y equals a times the absolute value of x minus h plus k. And the vertex of this one is defined. So y equals, again, we're not sure of the a yet, but x minus a -2, minus 6. And then again, my a value, well, it's at -2, 6, and again, it goes through the origin. So I'm just going to count a rise of 1, 2, 3, 4, 5, 6, and a run of 2. So a rise over a run, 6 over 2, is actually going to be a slope of 3. You can see that it actually goes through right there. So I could have counted up 3 and over 1. But now I just need to simplify this. So y equals 3. Absolute value of x minus a -2 is the same as x plus 2. And minus 6. And that is the example or the equation for that absolute value. Again, try to do some of the practice, and if you have any questions, either refer to come to class and ask more questions, please.